Hello everyone, my name is Rameshri. Today I am presenting my review of ML operations or ML ops, a critical engineering paradigm that bridges the gap between experimental machine learning and real world production grade systems. The real problem is stark. Up to 85% of ML projects never reach production. MLOps exists to fix that. MLOps extends DevOps principle to unique demands of ML systems. Unlike traditional software, ML models degrade over time as a data distribution shifts. A problem called drift is also observed. They require continuous retraining, reproducible pipelines, and complex infrastructure. MLOps provides the framework to manage all of this at scale. My review is grounded in the landmark paper by Chris Bunger and Harris, published in IEEE Access in 2023, which synthesized 27 academic articles, 11 MLOps tools, and interviews with 8 industrial experts. The framework centers on 9 principles. The most critical include CI/CD automation, which applies continuous integration and deployment to ML pipelines, workflow orchestration, which coordinates pipeline tasks using directed acyclic graphs, reproducibility and versioning, which ensures experiment can be rerun and audited, continuous training, which automates retraining when drift is detected, and continuous monitoring, which tracks model health in production. These 9 pipelines map onto 9 technical components from source code, repositories, and feature stores to model registries, serving infrastructure, and monitoring system. 7 roles bringing this to life, from data scientists and data engineers to DevOps engineers and cross-functional ML engineer who ties it all together. Despite the solid foundation, significant gaps remain. First, there is no standardized ML ops maturity framework. Unlike software engineering, which are CMMI, ML ops lacks a validated models for organization to benchmark progress from manual ML to full automation. Second, concept of drift management at scale remains unsolved. Error-based detectors require labeled data, which is often delayed in production. Distribution-based detectors suffer false positive in complex feature spaces. And in multi-model system, drift can cascade downstream in ways current tooling cannot handle. Third, data lineage and reproducibility at enterprise scale is extremely difficult, especially under regulations like GDPR, which provinces tracking across heterogeneous pipelines is both technically and legally demanding. Fourth, the skill gap is arguable, the biggest barrier. ML engineers must span data science, software engineering, and DevOps, competence not yet consistently taught together. Solid team structures further compound this. In summary, ML ops has a strong theoretical foundation, but practical adoption is constrained by tooling immaturity, workforce gaps, and organization inertia. Future research must prioritize empirical, longitudinal studies and develop actionable maturity frameworks. Advancing ML ops from best practice to universal discipline is one of the most conventional challenges in applied AI today. Thank you.